7.1b lesson. We're looking at area of kind of some funkier shapes. So the goal is you want to kind of partition these off and just add the little squares inside together. So inside here, 2, 3, 4, this is 12, and this is 1, and this is 1, so this should be 14. So 12 plus 1 plus 1, writing that down here, is 14 units squared. Okay, this guy right here, I chose to cut it this way. And this up here is 8 units, and this right here is 10 units. So 10 plus 8 is 18 units squared. Okay, for C, there's a rectangle in here that's easy, that's 10 units. And then there's a circle with radius 1, and it says to use 3.14. So I've got 10 plus pi r squared, pi r squared. So that's going to be 10 plus 3.14, which is 13.14 units squared. D, I chose to do it here. So I did this little section here is 8. And then I have 4 of the same triangles that are base 2 and height 1. 4 of the same triangles. So I've got an 8, and I've got 4 1/2 base times height, 4 of the same triangles. So 8 plus 4, which is 12 units squared. E, this guy right here, got 2 triangles. Okay, one of them, this guy right here is 2 by 1, and this guy right here is 2 by 2. So 1/2 base times height plus 1/2 base times height. So this would be 1 plus 2, which is 3 units squared. F, end up doing it this way, and this is 8, and then this is going to be 1, 2, 3, a triangle with base of 4, height of 2. 8 plus 1/2 base times height. That's going to end up being 8 plus 4 is 12 units squared. Okay, G, I think, was the hardest one on this paper. I'm going to come back to that one. Okay, let's do H. So I did this rectangle here, and this is 20. And this is half of a circle, half pi r squared, where r is 2. Okay, so I've got 20 plus half pi r squared. So 20 plus 2 pi. This would be half of 4, which is 2 pi. Pi is 3.14, so that's 20 plus 6.28, 26.28 units squared. Alrighty, this guy I went zoop, zoop. So this is 6. This is a half a unit, this is a half a unit. So both these together make a full unit. And this is a half of a triangle. So 6 plus a half and a half plus that triangle 1/2 base times height. So 6 plus 1 plus this comes out to be 1, so 8 units squared. J, let me come back to J. It kind of has to do with G. Let's do K. So let's do, well, this is just 1, 2, 3, 4.5. That was kind of easy, huh? Okay, maybe you did half or 4 and then did 1/2 base times height. Okay, so K is 1/2. Oh, I actually did that one as a trapezoid. Okay, so that's another way to do it. So I did 1/2 base 1 plus base 2, 1, 2, 3, 4. 5 plus 4 times 1. So that would end up being 4.5 units squared. Okay, but when I did that before, that's how I did it. But this is just 4.5. Easy to count. Okay. All right. L is another one of those ones. Okay, so L, we're going to look at this whole thing, and then we're going to subtract off these guys. Okay, so L, we have a, let's see what we have. We've got a 3 by 3. The pink square is a 3 by 3, and then we're going to take off 4 1/2 base times height. I'm taking off 4 of these triangles. So this would be 9 minus 4, which is 5 units squared. J, we're going to look at this whole thing and then take out these two and take out these two. Okay, so the whole thing is 1, 2, 3 by 1, 2, 3, 4, 5. 3 by 5, this is J. 3 by 5, and then we're going to take out, okay, do you see that this right here is 1 altogether? And then this is a half, this is 2 triangles, a half, 1 by 3. So 15, let me scooch it up so you can see the calculation, minus 1 minus 3. So I'm getting 11 units squared. Okay, now G's the hardest one on here. G, I ended up looking at like this. Okay, so I did the whole thing. 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 7 by 4. And then I'm taking out these pieces. Okay, let me take out this triangle. This is a 1 by 1, 2, 3, 4. I'm taking out, whoops, 1 by 4. Okay, and then this guy is a 1 by 1, 2, 3. Take out half of a 1 by 3. This guy is a 1 by 7. Take out a half, 1 by 7. And then this guy is a trapezoid. Couldn't remember the word. It's a trapezoid. So I need to take out 1/2. Base 1 and base 2, 1, 2, 3, 4, 1. So that's 4 plus 1, and then the height of it is 2. That's quite the formula. All right, so I'm going to kind of draw a line here telling everybody that that's the formula. Now let me start cranking out. 28 minus 2 minus 3/2 minus 7/2 minus 5. Okay, so 28 minus 2 is 26, minus 1.5 is 24.5. 24.5 minus 3.5 is 21, minus 5 is 16. And that's what I got before when I did it. Whew, that one was a beast. All right, so you should have exactly these answers. There are no other options. All right. So we're going to use the same knowledge that we just did, but we don't have a little grid paper behind it. Okay, so I'm looking at let's see what I've got here. A couple ways you could do this. You could divide this up in two and add them together, or couldn't we find the area of this whole thing and then subtract out this pink? That's what I'm going to do. Okay, so I'm going to do 7.9 times 7.9 minus 4.5 times 3. Okay, so this comes out to be 62.41 minus 13.5, 48.91 feet squared is the answer. All right, this guy. If I cut it right here, do you see that this parallelogram is the same as this parallelogram? So I've got two base times heights. So I've got two 30 by 40s. So that's 2,400 centimeters squared. Okay, this guy, I think I'm going to do the area of this plus the area of that. Okay, so it's very important to understand here to here is 9.3 plus 9.3 plus 23.7. So let me mark that. 42.3 meters there. And then this right here is going to be 49.8 minus 32.4, and that's 17.4 meters. Okay, so the area of this rectangle here is 23.7 times 32.4. And then I'm going to add 1/2 base times height. So there's my formula. This comes out to be 767.88 plus, and then this comes out to be 368.01, and altogether 1,135.89 meters squared. All righty, last page. A rectangular field with two semicircles at each of the shorter ends of the field measures 100 yards long and 40 yards wide. It is surrounded by a track that is 5 yards wide. Find the area of the field, which includes the two semicircles on each of the shorter ends of the field. Find the area of the track. All right, so this is what we're finding in pink. And then we're going to find this green track after. Okay, so I'll do it in two colors. All right, so I'm going to be doing, I'm going to find the area of this inside here, which is 100 by 40. 100 by 40. And then do you understand this? These two half circles put together are going to be a full circle with a radius of 20. So there's my formula for the area of the field, the pink. Okay, so this is 4,000 plus 400 times 3.14. Okay, we're roughly, we've taken pi out, so we're not getting an exact answer, we're getting an approximated answer because we're using 3.14 for pi. So 4,000 plus 1,256, and that comes out to be 5256 yards squared is the area of the field. Okay, now let's do the area of the track. So doesn't it make sense that we just found the area of that pink field? We need to do the same thing, but with the entire green field. Okay, so we've got, let's see here, 100 this way, and 40 plus 5 and 5. So it's going to be 50 this way and 100. Okay, and then we're going to go ahead and add on. We're going to add on pi r squared, this whole circle, these two semicircles put together make a full circle. Okay, so let's think about this. 25 is going to be my radius. Okay, if I've got 40 and then 5 and then 5, that would be 50. So 25 pi 25 squared. Okay, so this gets me 5,000 plus 25 times 25. I think that's 625. Let me double check. 25 times 25. Yeah. 625 pi. You know what? Instead of the pi, I'm going to put the 3.14 in. Times 3.14. 1962.5. Okay. Let's see here. So that's the area of the entire thing, but that doesn't make sense because this should be bigger than this. Let me see what happened just now. $100 times 50 plus those two circles, 25, yeah. Oh, it just didn't add that up right. That's why it doesn't make any sense. 5,000, my calculator steered me wrong, guys. 5,000 plus that, 625 times 3.14 plus the 5,000. Here we go, 6962.5 yards squared is the area of the field plus the track. So you have to subtract those. 6962.5 minus 5256. So 1706.5 yards squared is just the track area. Whew, that was a doozy. Okay, one last problem with 3 parts. Hugo is making the tile pattern shown. The tile is a square with 4 circles of the same, of the same size and side. He will paint the circles blue and the remaining part of the tile yellow. Find the area of the portion of the tile that will be yellow. Okay, so let me go get a couple. Let me go get a blue and a yellow marker. Do I have one right here? Blue, but I don't have yellow. Let me go get yellow. All right, so that's yellow, that's yellow, that's yellow. Yellow, 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 and yellow. And then the circles are blue. All right, find the area of the portion of the tile that will be yellow, round to the nearest hundredth. All right, so doesn't it make sense that we're going to find the area of the whole thing, and then we're going to take out the 4 circles. If we do that, we'd be left with just the yellow stuff. Okay, so this is going to be 12 by 12. And then we're going to minus 4 pi. Can I be really careful here? If the diameter is 6 on each of these, isn't the radius 3? So we're going to have 144 minus, this comes out to be 9 times 4, 36 pi. And if we use 3.14 in here, we end up with about 30.96 inches squared of yellow. Find the area of the diamond-shaped piece in the middle of the tile. Okay, well, here's one diamond-shaped piece. Okay, doesn't these 2 make another diamond-shaped piece? And don't these 3 make a diamond-shaped piece, and same with this? So there are a total of 4 diamond-shaped pieces. So if you take that 30.96 and cut it in quarters, that comes out to be 7.74 inches squared. What percent of the tile will be yellow? Okay, so the yellow portion is 30.96 and the entire thing is 144, and that comes out to be, so about 21.5% is yellow. Okie doke, guys. Minimize that.